Okay, so in this uh, particular rest of this lesson, what we're going to be doing is some of the problems that you hopefully have already tried by yourself. So this is kind of just as a check to make sure that you got the answers correct, as well as to clarify any questions that you may have depending upon whether or not you got the questions right or not. So two friends start walking on a football field in the same direction. Person A walks twice as fast as person B. However, person B has a head start of 20 meters. If person A walks at 3 meters per second, find the distance between the two friends after walking for 20 seconds and determine who is ahead at this time. Oh, give me a second. Okay, so what this is saying is, first of all, we are going to draw a picture. So I've got person A, okay, and then I've got person B. He's got a head start of 20 meters. So here, 20 meters. Okay, person A though walks twice as fast as person B. However, person B has a 20-minute head start. If person A walks at a velocity of 3.0 meters per second, find the distance between the two after walking 20 seconds. So if person A walks twice as fast as person B, then we know person B must walk at 1.5 meters per second. Okay, and the question is asking us about a time of 20 seconds. What's going on there? So let's again record down kind of the things that we know and versus what we don't know. So we know that the velocity of person A is 3.0 meters per second. We know the velocity of person B is 1.5 meters per second. We know that the time the question is asking us for is 20 seconds. We also know that um, the distance a person B has is going to be kind of this added 20 meters as a memo to myself. Okay, so the question is asking who is ahead at this time, position time graph. So the question is asking us for the displacement of person A and finally the displacement of person B. So V equals d over t. So if I was to try to figure out displacement, I need to times both sides by t in order to cancel out time. So I know d is v times t. So for person A, this is simple. We are going to be talking about 3.0 meters per second. We're going to multiply that by 20 seconds. Okay, so I get 6 meters. Oh, sorry, 60 meters. Okay, right? 3 times 20, 60 meters. Now, B, you're going to look at the velocity of B is only 1.5 meters per second. We're going to times that by 20 seconds. And that is, so 1.5 times 20, we now got 30 meters. But remember, B has this plus 20 meters that he originally had, so he traveled 50 meters in comparison to where A started. So, in effect, person A is 10 meters in front of person B. Now, if I was to draw a displacement versus time graph, okay, this was person A's line. Okay, person B would be starting 20 meters ahead. Okay, and their slope would not be as steep. Okay, and this point, this point here would be 50 meters, and this is going to be 60 meters. Though I guess I should put these so that they're like this. So 50 meters, and this would have been a time of 20 seconds. It's kind of what we're looking for. And at some point there, person A would have overtaken person B at this point here. All right, so let's try our next question. So, a camper kayaks 16 kilometers east from a camping site, stops, and then paddles 23 kilometers west. What is the camper's final position with respect to the campsite? Well, campsite, okay. Camper kayaks 16 kilometers east from a camping site. So, in this case, we're going to do east, west, okay, something like this, okay. So, 16 kilometers, turns around and paddles, then 23 kilometers. And we're going to say that's a negative. So this is the distance first that they traveled. This is the distance second that they traveled. Um, so we are going to then do their total displacement is d1 plus d2. D1 is 16, positive 16 kilometers plus this negative 23 kilometers. So we're going to do 16 plus negative 23. Now, 23 is negative because it is in the opposite direction. So we get negative 7 kilometers, which means that the camper is 7 kilometers west of the campsite. This question is really asking for what the displacement is, right? If the question was asking what the distance was, then we would be adding them together without respect to what direction. Okay, so keep that in mind. All right, so next question here. Sketch a position time graph for a bear, starting 1.2 meters from a reference point, walking slowly away at a constant velocity for 3 seconds, stopping for 5 seconds, backing up half the speed for 2 seconds, and finally stopping. So this is my reference point. This is going to be distance. So he starts 1.2 meters away, okay, from a reference point. He's going to walk slowly away at a constant velocity for 3 seconds. So 3 seconds. Then there's another situation that happens. Oh, sorry. Okay, so let's just deal with this first. So here we go. So 1.2, we're going to walk away. Okay, now we're going to so walking away at a constant velocity. We're going to stop for 5 seconds. So over those 5 seconds, my displacement hasn't changed. This would be now at 8 seconds. Then he's going to back up at half the speed for 2 seconds. So we're finally at 10 seconds is going to be the final. And now half the speed means that this is going to be significantly shallower than my previous line here. Okay, and finally stopping straight again. Okay, so that would be the position time graph for the bear in this particular question. All right, next question. Sketch a position time graph for a student walking east to school with a constant velocity, stopping at school, which is 5 kilometers east of home, and then cycling home with a constant velocity. So, okay, position, time. I'm going to say the reference point here is going to be home. Okay, we're going to say this is distance in kilometers east. Okay, and here is going to be 5 kilometers. So we imagine that the kid walks to school, stays at school for some significant period of time, then he's going to cycle home with a constant velocity. Cycling is going to be significantly faster than walking, so we expect something much steeper in my line, okay? So that's really what that question is asking for, is something that looks like this. All right, question 9. An insect moves 5.0 meters per minute. An insect B moves 9 centimeters per second. Determine which insect is ahead and by how much after 3 minutes. We're going to assume both insects are moving in the same direction. So we're going to have kind of like a starting line, right? We're going to have an insect moving in one direction, that's insect A, and then insect B. Okay, and the other, or the same direction. Insect A is 5.0 meters per minute. Insect B is 9.0 centimeters per second. Sorry, centimeters per second. The question is asking me kind of what is the displacement after 3.0 meters. Okay, so things that I know the velocity of insect A at 5.0 meters per minute. I know the velocity of insect B at 9.0 centimeters per second. Okay, and then I know, sorry, centimeters per second, and the time I know of 3.0 minutes. Okay, and the question is asking me for the displacement of insect A versus the displacement of insect B. Okay, so I know velocity is equal to displacement over time. Displacement is equal to, V times t. Okay, so if we're talking about insect A, okay, insect A's velocity is 5.0 meters per minute. Now I'm going to use the same unit of time, so I'm going to times this by 3.0 minutes. And insect A would have traveled 15 meters. Okay. Now for insect B, okay, his velocity is 9.0 centimeters per second. Now I need to have the same unit of time, so I need to figure out what 3.0 meters, or sorry, minutes is in seconds. And I need to do that by multiplying 3 by the 60 seconds in each minute. So I get 180 seconds. So times by 180 seconds. Okay, so times by 9. And I get 1,620 centimeters. So now I need to go from centimeters to meters. And if I look at the first page there in my data booklet, I've got conversion factors. So I'm going to look at the centi one. So I'm going to multiply this by the conversion factor listed there of 0.01. So times 0.01, enter, and I get 16.20 centimeters, or sorry, not centimeters anymore, meters, which means that insect B will be ahead by 1.2 meters in 3 minutes. Okay? All right. Here we go. Next question. Match each velocity time graph below with the correct statement. So this is kind of like do you understand what's going on here? So note that these are velocity time graphs. Okay, velocity, time. Okay, so negative acceleration means that the object is slowing down, so its velocity is decreasing. So that's A. B says, or sorry, the next one is positive acceleration, which would mean that the velocity is increasing, and that's B. Okay. Moving with zero acceleration means that I'm traveling at a constant velocity, and that is C. And then finally here, stationary object's going to have a velocity of 0. Hopefully you can see there that the line is right along the like the x-axis, so this must be 4. All right. Question 15. A motorbike increases its velocity from 20 meters per second to 30 meters per second over a distance of 200 meters. Find the acceleration and the time that it takes to travel this distance. So, a few things here. We're talking about a motorbike. Okay, there we go. Uh, Traveling, and he's accelerating. Okay, so we've got a few values here. I've got 20.0 meters per second west. I've got 30.0 meters per second west. Okay, and I've got 200 meters. Meters is displacement, meters per second, those are velocities. So I need to figure out which is my initial, which is my final. It says it increases its velocity from 20 meters per second. That must be its initial. To 30 mean its final. This question is asking me what is the acceleration and what is the time. Okay, so what I'm going to do here is I'm going to be using my um, data booklet here. And what I'm going to do is I'm going to first look for an equation that has these 4 variables in it. Okay, so I'm going to solve for acceleration first. Okay, so I am looking here and I find hmm, actually I'm actually going to solve for t first. Sorry. Okay, so I'm going to be looking for these guys first. And I found the formula here at delta D equals VI plus VF all over 2 times time. So I need to solve for t. So I need to divide both sides by this whole section here. So I've got delta D all over VI plus VF divided by 2 equals t. All right, so it says over 200 meters, so 200 divided by 20 meters per second plus 30 meters per second. Sorry here, all divided by 2. So I'm going to do the first portion first. So 20 plus 30, enter, divided by 2. So 25, that means the denominator there is 25. So 200 divided by 25 gives me a time of 8 seconds. Okay, so now I'm going to be looking for something that contains kind of as many as possible where I'm solving for acceleration. And what I'm going to do here is I'm just going to use my simple acceleration equals a change in velocity over a change in time. So this means VF minus VI all over t. So I've got 30 meters per second minus 20 meters per second all over 8 seconds. So that it would equal 10. Well, let's just do the calculation. 30 minus 20 gives me 10 divided by 8. So 1.25. So an acceleration of 1.25 meters per second squared. And the direction on this, because acceleration is a vector, is west. Beautiful. 2 calculations, 2 answers. It looks lovely. All right, 16. While driving north from Lake Louise to Jasper, you travel 75 minutes at a velocity of 70 kilometers per hour and another 96 minutes at 90 kilometers per hour. Calculate your average velocity. Okay, so here we go. We got kind of these 2 sections of my trip where we've got Lake Louise. Okay, I'm going to travel to Jasper. But I've got these 2 portions. I've got portion A where I travel 70 kilometers per hour going to say this is portion A. Okay, for 75 minutes. Okay, and then I've got this 90 km per hour part B, where I am traveling for 96 minutes. Okay, so calculate my average velocity. So I've got a few things here. I've got the velocity of A is 70 kilometers per hour. I've got the time for that is 75 minutes. I've got a velocity of B, which is 90 kilometers per hour, and I've got a time for portion B at 96 minutes. In order to calculate my average velocity, I need the total displacement over the total time. So I need to figure out the displacement total, which is going to be the displacement of A plus the displacement of B. Okay, and I'm going to need the time total, which is going to be time A plus time B. I do not have the displacement of A or the displacement of B, so I will need to calculate those out along with my velocity total. Okay, so in order to figure out time total, that's going to be pretty easy. Okay, I'm going to take my 75 minutes plus 96 minutes, and I get 171 minutes. I'm going to convert those to hours. So in order to convert to hours, I'm going to divide that by 60. Because there's 60 hours, 60 minutes in an hour. So I get 2.85 hours is my total time. Now I need to figure out the distance traveled. So to rearrange, B equals D over T. D is equal to V times T. So if I'm looking at the A portion here, okay, I need to make sure though that my time units work. So I'm going to do 75 divided by 60. It's going to give me a little over an hour. So 1.25 hours here, 1.25 hours. Okay, and then I'm just going to quickly here do the 96 minutes. Okay, that's 1.6 hours here. So 1.6 hours. Okay, so my velocity for my first part is 70 kilometers per hour. Now, this is why I had to change my time because this is per hour. So now I'm going to times that by 1.25 hours. And I'm going to get an answer in kilometers. Okay, so 1.25 times my 70 is going to give me 87.5 kilometers. Okay, so now we're going to look at the second section of our trip here. So portion B. In portion B, I'm traveling 90 kilometers per hour, and I am doing that for 1.6 hours. So go back to my calculator here, 90 times 1.6, and I traveled 144 kilometers in that time. So my distance of A is 87.5 kilometers. My distance of B is 144 kilometers. So my distance total is 87.5 plus 144. So here we go, plus 87.5 gives me 231.5 kilometers. So my average speed is my distance total over my time total, which means 231.5 kilometers in 2.85 hours. So figuring that out here, 231.5 divided by 2.85 gives me a total of 81.22 kilometers per hour. So now for significant figures, I'm going to look back up at my question. I've got two significant figures and everything, which means that I need to report to two significant figures. So 81 kilometers per hour was my average velocity. All right. Here we go. Next question. How far will a humanoid robot travel in 3 seconds, accelerating from one, accelerating at 1 centimeter per second squared forward if its initial velocity is 5 centimeters per second? So we've got a few values here. I've got 1.0 centimeters per second squared. I've got a 5.0 centimeters per second, and then I got a 3.0 seconds. So seconds, time, distance over time, that's a velocity. Distance over time squared, that's an acceleration. Okay, the question is asking you how far will the um, robot travel, that's a displacement. And it also says initial velocity, so that's VI. So I'm looking for a formula that has acceleration, velocity initial, time, and displacement in it. And I would find the formula D equals VIT plus a half AT squared. So I'm going to just keep everything because they're all in centimeters per second. So I'm going to just keep those values there, and then my displacement is going to be in centimeters, so that's beautiful here. So this is 5.0 centimeters per second multiplied by 3.0 seconds plus, I'm just going to move this down here, a half times 1.0 centimeters per second squared multiplied by 3.0 seconds, and that's going to be, oh, sorry, squared, not cubed here, squared. Okay, so plugging this into my calculator, I'm just going to put some brackets around the first components as well as some brackets around the second components here just to keep everything straight. So I've got 5 times 3 plus a half, so 0.5 times 1 times 3 squared. Enter. So I've got 19.5, so this displacement is 19.5, keeping the same units, centimeters. And this would be obviously forward. All right. Here we go. Next question. What is the displacement of a logging truck accelerating from 10 meters per second right to 20 meters per second right in 5 seconds? So I've got the values here of 10 meters per second right. Okay, I've got 20 meters per second right, and I've got 5.0 seconds. Seconds is a unit of time. These are both units of velocity. Question is, which one's initial, which one's final? Well, if I read the question again, it would tell me that that one's initial and that one's final. The question is asking me for the displacement. I look again in my data booklet, and I find a formula with all of those in it. Solving already for D, which is really nice. So D equals VI plus VF all over 2 multiplied by time. So VI 10 meters per second plus 20 meters per second all divided by 2 multiplied by time of 5.0 seconds. So to my calculator here, I can just do so 10 plus 20, that gives me 30, divided by 2 gives me 15, and I'm going to multiply that now by 5. Okay, so 75, the distance traveled there is 75 meters, and we would put right. Beautiful. All right, how far will a car travel if it starts from rest and experiences an acceleration of a magnitude of 3.75 meters per second squared forward for 5.65 seconds? All right, so I've got some values, 3.75 meters per second squared. I've got 5.65 seconds. Seconds is a unit of time. Meters per second squared, that's a unit of acceleration. It says it starts from rest, so the initial velocity is 0 meters per second. Okay, the question asks how far a car will travel, so that's asking me for D. So I'm going to look, see which one has all of those. I see D equals VIT plus a half AT squared. So initial velocity in this case is 0, so I can cancel that right out, that whole part there. So now I got a half plus, sorry, not a half plus, sorry, a half times acceleration, which in this case is 3.75 meters per second squared, times that by 5.65 seconds, and that is going to be squared. All right, so here we go. I've got this calculation, so point 0.5 times 3.75 times 5.65. We're going to square that last value, enter. We've got 59. D equals 59.85 meters. I'm going to look at my significant figures here. I've got 3 significant figures, so this turns into 59.9 meters. All right, here we go. Next question. Determine the acceleration of a bullet starting from rest and leaving the muzzle in 2.75 times 10 to the negative 3 seconds later with a velocity of 460 meters per second forward. So I've got a few things here. I've got 2.75 times 10 to the negative 3 seconds. Seconds is a unit of time. It says that it is traveling at a velocity of 460 meters per second. This is forward. Okay. It says that the bullet is starting from rest, so that means its initial velocity of 0.0 meters per second. Okay, and the question is asking me for the acceleration. So I'm going to look at my data booklet here, and I see that acceleration equals a change in velocity over a change in time. So that means Vf minus Vi all over t. So Vf is 460 meters per second minus 0 meters per second all over a time of 2.75 times 10 to the negative 3 seconds. So when I go to put this in my calculator here, I can just do 460. Now I don't have to do the minus 0 because that still keeps it 460. Divided by bracket, so 2.75 times 10 to the exponent negative 3. Take my bracket. Oh, sorry, I should delete that here. Take my bracket down. Okay, and enter. So I've got a very, very high number. Just to make sure here, 460 divided by 0.00275. Okay, if I put in the decimal, same number, perfect. So I did my calculation correct. So 16772.72 meters per second squared. I've got 3 significant digits and everything, so I need to report this in 3 significant figures. So acceleration is 1.67 times 10 to the 1, 2, 3, 4, 5 meters per second squared is my answer. And that would obviously be, sorry, forward. Okay, wherever the gun is pointing. All right, so this next question here, some aircrafts are capable of accelerations to a magnitude of 42.5 meters per second squared. If an aircraft starts from rest, how long will it take the aircraft to travel down the 2.6 kilometer runway? Well, I've got some values here. So 2.6 kilometers. I've got from rest, so 0.0 meters per second. This is VI. Okay. And I've got an acceleration of 42.5 meters per second squared. This is distance. I'm going to convert this to meters. So 2,600 meters. Okay. Here we go. So the question asked me how long, so we're looking for the time. So I'm going to look for an equation that has all of those in it, and I would see D equals VIT plus a half AT squared. Okay, VI is 0, so that cancels out. So D equals a half AT squared. I'm trying to solve for T, so I just need to rearrange this a little bit. I'm going to divide both sides by a half A. So this turns it into 2D all over A. Sorry, a half A equals T squared. So in order to get the squared away, I do the square root of 2D all over A gives me my T squared. So that, or sorry, gives me my T. So this is a square root of D was 2,600 meters all over an acceleration, or sorry, so this would be 2 times that number, all over 42.5 meters per second squared. So I like to do my calculation first and then the square root after. So I'm just going to do 2 times 2,600 divided by 42.5. Okay, and with that number, I know I'm going to do the second square root of that answer, and I get 11 seconds. All right, so we're going to just record that down here. So time is equal to 11.06 seconds. Significant figures are 3, so this would be 11.1 seconds as time. Okay, so question number 6 here. If a cyclist is traveling at 14 meters per second and he skids to a stop in 5.6 seconds, determine the skidding distance. Assume uniform acceleration. So we've got a few things here. I've got 14.0 meters per second. Okay, he stops in a time of 5.60 seconds. It says that he stops. So in this case now, the final velocity is 0.0 meters per second. Seconds is a unit of time, and meters per second, this is velocity, but this is the initial velocity that the cyclist is traveling. We're going to assume uniform acceleration, and it says that the question is asking you for displacement. How far? Okay, so I'm going to use in my data booklet, I'm going to look and find a formula that contains these 4 things. Okay, so final, initial velocity, time, and displacement. And I would see that displacement equals VI plus VF all over 2 multiplied by time. So I've got now VI, so 14.0 meters per second plus 0.0 meters per second all over 2 multiplied by time, and the time is 5.60 seconds. So I'm going to do, clear here, sorry. 14 plus 0, well, that's just 14 divided by 2, and then we're going to times that by 5.6. And I've got an answer of 39.2 meters. 39.2 meters. Proper amount of significant figures, so I don't have to worry about it at all. Okay, here. So question number 7. Approaching a flashing pedestrian activated traffic light, a driver must slow down to a speed of 30 kilometers per hour. If the crosswalk is 150 meters away and the vehicle's initial speed is 50 kilometers per hour, what must be the magnitude of the car's acceleration in order to reach this speed limit? Okay, so I've got quite a few values here. 30 kilometers per hour. I've got 150 meters. I've got 50 kilometers per hour. So initial speed, VI here at 50. Final speed, they need to slow down to 30 kilometers per hour. And it's 150 meters away, so that's D. The question is asking me for what is my acceleration. So here we go. What we need to do here is we're going to need to calculate time. Okay, so I'm going to solve these ones first. And I'm going to look again without acceleration. I get D equals VI plus VF all over 2 times by time. So I need to divide both sides by VI plus VF all over 2. VI plus VF all over 2. okay, equals D. So T is equal to D divided by VI plus VF all over 2. Okay, so here we go. I'm going to calculate time in this manner. Now, I've got some kilometers per hour and some meters. So what I need to do is need to convert these kilometers per hour into meters per second. I divide each by 3.6 in order to figure that out. So 30 divided by 3.6, and I get 8.3 repeating. Sorry, equals 8.3 repeating meters per second. And then I've got 50 divided by 3.6, and I get 13.8 repeating meters per second. Okay, so this turns into 13.8 repeating plus 8.3 repeating all over 2. Oh, sorry. And then D, sorry, D is 150, so we're going to divide that there. Sorry that this is all a mess here. But so what I'm going to do here is first I'm just going to add these two numbers together. So I'm going to do this number, so 13.8 repeating, sorry, plus 8.3 repeating. Okay, and I get 22.2 repeating. I'm going to divide that number by 2 to get 11.1 repeating. Now I'm going to do 150 divided by that answer. And I get 13.5. So the time that it took him to slow down was 13.5 seconds. So 13.5 seconds. Now I'm going to figure out the acceleration. Acceleration is a change in velocity or a change in time. So VF minus VI all over T. So the final velocity there is the 8.3 meters per second minus the 13.8 meters per second. Oh, 13.8 repeating. The 8's repeating, not the 13. Okay, all over the 13.5 seconds. So in order to do this, again, wanting to keep as many significant figures as you can, I'm going to take the values already in my calculator. So I'm going to do 8.3 repeating minus my 13.8 repeating. Solve for that. So I've got a negative value. Now I'm going to divide that by 13.5. And I get negative 0.41. So equals, so acceleration equals negative 0.411 meters per second squared. Proper amount of significant figures here is 2. So this goes negative 0.41 meters per second squared. Negative meaning we're decelerating, right? So we're slowing down, which makes sense given the question. All right, so this brings us to the end of all of these practice questions. Again, if you have any questions, make sure that you bring them up because kind of at this point, we're going to be doing a test. So it's very important that you understand these sorts of concepts and how to calculate these sorts of questions. With that, again, this is the end of the lesson. Thank you very much.